Thank you. Thanks for coming. Is Ian Bicking in the house? I've got my scalpel right here. We can get started. No. We're going to do this black box style. Yeah, this is an extreme talk. I'm going to be assuming that you know pip and virtualenv, that you use them. We're going to dive right into the guts. So hope that's what you came for. We're going to build a virtualenv from scratch. The goal is fully isolated environments. We want the virtualenv to have its own site packages directory and use that for imports and installation, and ignore the system site packages. That'll be our initial goal, at least. So what is site packages? When you install a third-party module that's not part of the standard library, that's where it goes. On my system, Python, on my Ubuntu system, this is where site packages lives. The standard library is in userlib Python 2.6. Site packages lives under that. So the way site packages happens is that when Python starts up, it automatically imports a module called site.py, which lives in the standard library. Or if you're looking for it in the Python source tree, it's under lib site.py. You don't need to read all of this. This is a bit of code out of site.py, and this is the bit of code that determines where site packages is. So this is where we need to look if we're trying to change the location of site packages for our virtualenv. The important bits here, up top, we define a prefixes that include sys.prefix and sys.exec prefix. And then within the function, it loops through those prefixes. And for each prefix that it loops through, it does a bunch of platform-specific stuff, depending which platform you're on. For platforms that I use, it's the os.sep // and there you get lib python x.x, where x.x is sys.version, more or less, site packages. So that's how site packages is found. So it all comes back to sys.prefix. Whoops. So sys.prefix comes from Python sysmodule.c. It's a module defined in C code. And if we continue to follow down from there, we actually find that sys.prefix comes from modules getpath.c. And here's a bit of the C code from getpath.c. I don't actually expect you to read C code on a slide, but so I will just move on and we'll talk about what this actually does. If there's a Python home environment variable set, that's sys.prefix, no questions asked. Otherwise, we start from wherever the Python binary is located that we're running and look for the relative path lib python x.x, where x.x again is the version of Python you're running, os.py. If that exists, we've found sys.prefix. If we never find that, we fall back on the prefix that was hard-coded into Python at build time, if you use configure --prefix when you build it. I don't know why os.py is the hard-coded landmark. I haven't looked back in the Python version history to find out what justified that. I guess it's a module that you always need, so maybe that's a good enough reason. You can see right there where it's hard-coded. So let's do this. You can follow along if you want. I'll try to go slow enough that that's possible. The examples are all pulled from a stock Ubuntu Python 2.6 installation, so it'll go most smoothly if you have that, but it can work for other versions. So we make a scratch directory, we cd into it, we make a bin directory within our virtualenv, and we copy the Python binary into it. So this is what our virtualenv looks like. So we'll just test it here. We just run a quick command to see what the value of sys.prefix is. It's /usr. So our virtualenv isn't working yet. The reason it's still USR, there's no Python home environment variable set. This is where the binary is. This file doesn't exist, nor this one, or this one, or that one. So we fall back to the build prefix, which in this case is /usr. So let's try creating the landmark. We're not going to put anything in it, it's just an empty file. So this is what our virtualenv looks like now. It has a Python binary under bin, and it has an os.py empty file. And we've got it. sys.prefix is now home carl.jm scratch. And if we check sys.path, which determines, of course, where things are imported from, we see that almost all of the sys.path entries are now within our virtualenv. So it is now ignoring the system Python, except for that one at the end, libdynload. We'll take a brief excursus to figure that out. That actually comes from the other prefix, sys.exec prefix. It's supposed to be where compiled C modules go. So we can fix that too. The hard-coded landmark for that one is actually the libdynload directory. So if we make that directory in our virtualenv, and then we check exec prefix, now exec prefix is also in our virtualenv. And now if we check the sys.path, we're completely isolated. Nothing will be imported from the system Python at all, only from inside our virtualenv. So we win, except we don't win. We don't have a standard library. There's no site.py. You probably saw the error messages that I glossed over, talking about how site.py couldn't be imported. So without site.py, we don't even have any site packages. Most obvious approach, we could copy the entire standard library. That actually works great, no problems. It's just a little bit heavy. If you have 30 virtualenvs on your system, I think the standard library is in the range of 100 megabytes, something like that. So I know disk space is cheap, but we probably would like to avoid that if we can, especially since the standard library is going to be the same in every single virtualenv. So here's how virtualenv actually does it. At this point, I'm going to stop actually doing it as we go because it gets kind of complicated and hacky. We're going to cheat and look in the book and see how virtualenv actually does it. What virtualenv does, when you create a virtualenv, it writes a file origeprefix.txt into the lib directory of your virtualenv, and the contents of that file is just a single string, the system sys.prefix. So in the case of my system Python /usr. So we have that origeprefix.txt file that tells us what the prefix of the system Python is, and then we place our own modified site.py into the lib directory, and we hack it up so that it reads origeprefix.txt and adds system standard library paths to sys.path as well. So this is what our hypothetical virtualenv from scratch might look like now. You see the addition of origeprefix.txt and site.py. And here's a bit of code from virtualenv's actual site.py. It adds this function that doesn't exist in the normal Python site.py, virtual install main packages. It opens up the origeprefix.txt file, reads its contents, and assigns that to the attribute sys.realprefix. As a brief side note, this came up recently on the virtualenv mailing list. If you have code that wants to detect at runtime whether you're inside a virtualenv or not, which you probably shouldn't do, it's supposed to be transparent, but if you have some good reason for doing that, checking for the existence of sys.realprefix is the best way to do it. That attribute of the sys module won't exist unless you're in a virtualenv. So then after we've got sys.realprefix, then we go through, and again, it's a little bit platform dependent, but based on sys.realprefix, we find where the standard library should be, and we extend sys.path with that. Yeah, we have a problem still. If you go back and look at this slide, where do you think os.path.join comes from? Yeah, bootstrapping issue. So virtualenv's solution is to symlink or copy, depending on what kind of operating system you're on, just the standard lib bits that you need to import os.py, to import the OS module and os.path and all that, which includes, of course, anything that OS imports, so it expands out a bit. But we symlink or copy just those bits into our virtualenv in advance when we create the virtualenv. And that's just enough so that site.py is able to run. And after site.py runs, of course, then we have the full standard library available to us because we've added it to sys.path. Here's how virtualenv.py actually does that. We have a list of required modules. Those are the ones that you can't run site.py without. And I'm actually making it look nicer than it really is, because what you really have in virtualenv.py, after that required modules definition, you have if Python version is 2.5, add these modules. If it's 2.6, add these modules. Because in each version of Python, the Python developers don't necessarily take care to make sure that OS always imports only the same set of modules. So depending which Python version you're running, it could be a different set of Bootstrap modules you need. And then virtualenv actually loops through that list of required modules and symlinks or copies each one in turn into the virtualenv. And then we can also add the global site packages if we want it. It's a little bit backwards. When you actually use virtualenv, the default is to link in the global site packages, but in actual fact, the way virtualenv works, it's isolated by default. And if you want the global site packages, it does a little extra work to give them to you. It looks something like this. It just, if you want the global site packages, it makes an extra call to add in the site packages using sys.real prefix instead of sys.prefix. So you also get the global site packages. Oh, we have a problem again. I blame this on Emacs, by the way. Emacs and its backup files. All right. So, conclusion. What makes a virtualenv actually work is the location of its binary and its hacked up site.py. So if you aren't using the virtualenv's binary, you aren't really using the virtualenv. So what about bin activate? This is most people's entry point into a virtualenv. All it actually is a shell convenience, and what it actually does, aside from setting some additional convenience environment variables, is it adds the virtualenv's bin directory to the front of your shell path. So that when you run Python at your shell, it runs the virtualenv's Python binary instead of the system one, and then all of the actual machinery we've been talking about comes into play. I actually blame bin activate for most of the support issues on the virtualenv mailing list with people not understanding how virtualenv works. So what often happens is somebody installs IPython in their global Python environment, and then they have a virtualenv and they activate it, and they think, well, I've got my virtualenv activated, so everything I do in Python should be in my virtualenv. Actually, if you don't have IPython installed inside the virtualenv, when you type IPython at your shell, it doesn't matter that your shell path has the virtualenv's bin directory in front of it because there is no IPython in the virtualenv's bin directory. So it goes right ahead, uses the system IPython. The system IPython script refers to the system Python binary in its shebang line, and so IPython couldn't care less about your virtualenv. It won't be able to import anything in your virtualenv. So bin activate, all it does is modify your shell, and you can use it, but it's a bad model for actually understanding how virtualenv works. It's much more helpful if you focus on, am I using the virtualenv's Python binary or not? Some problems with virtualenv. One is, we just talked about, sometimes you can't use the virtualenv's Python binary. One instance is if you're trying to deploy a website on ModWSGI. ModWSGI is going to want to use the global system Python, probably. So people have various tricks they try to use a virtualenv without really using it. Here's 3 of them. I don't think I have time to actually go into details on pros and cons of each of these. All of these, probably the third one is your best bet. It comes the closest to actually simulating what a virtualenv does, but it also modifies sys.prefix, and the maintainer of ModWSGI, Graham Dumpleton, says that's a bad idea. I don't know exactly why, but if you look at the ModWSGI docs, they essentially have a copy of activate_this.py with the bits that modify sys.prefix removed, and that's what they tell you to use. So anyway, that's another discussion. Another problem with virtualenv is it has this forked site.py business, which is kind of ugly. Site.py gets modified. Distributors modify it. Debian and Ubuntu have this dist packages thing. That's implemented in site.py. There was a period of time when they first did that when you couldn't actually use virtualenv on Debian or Ubuntu properly because virtualenv's hacked copy of site.py hadn't caught up with the changes that Debian made. Also, new Python versions modify site.py, and then virtualenv has to catch up with that or it won't work. I'm going to skip very quickly over these other virtualenv approaches. Virtualenv small site.py tries to solve that problem by making virtualenv site.py a wrapper around the global one. That's a neat idea. It's not quite there yet. You could work on it. Our virtualenv is a completely different approach you can check out. Has some advantages, has some disadvantages. Another alternative is just use Python home. We don't need the copied binary. It still requires the standard library stuff we did. It makes it harder to pin a virtualenv to a Python version because you aren't actually copying the proper binary into it. Ian doesn't like environment variables. That's why virtualenv doesn't do this. Using environment variables is a little more fragile because things can change them. There's also this Python v, which might be a direction for actually getting something like virtualenv into Python itself. And we have this problem again. No wonder I'm running out of time. Okay, pip. Pip installs Python packages. Ready? So this is the, if you like, the inner sanctum of pip. This is where the actual installation of a package happens with much ritual and ceremony. So here's a translation of what that, if we go back to that slide, all this actually is a subprocess call. So pip actually installs things in a separate subprocess. And this is a translation of what that subprocess call would actually look like if you just wrote it out in the shell. We'll go through that line by line real quick. So this is the core of the ugly hack. I assume most of you know that there's distutils in the standard library, which is a packaging solution that is sort of halfway there. And then there's setup tools, which is a third-party module written by Philip Eby that extends distutils by monkey patching it, which is kind of distutils' fault, really. But anyway, the point is it monkey patches, and so if you import it, then it takes effect, it takes over. And so all pip has to do is import setup tools, and then using exec file, it runs your setup.py. And the reason pip does this is that pip wants to be able to treat all packages consistently and do setup tools things to them, like generating metadata, things that distutils can't do. Also develop or editable installs, that comes from setup tools. So in order to be able to do that with all packages, even if they use only distutils in their setup.py, pip just runs roughshod over that. If you're a purist and you don't like setup tools and you write a package with a setup.py with only distutils in it, doesn't matter. Pip imports setup tools and just goes ahead and uses it anyway. Then install. This is just like a normal Python setup.py install. Then there's this single version externally managed. This tells setup tools to do a flat install instead of a zipped egg or egg directory install, which is what setup tools likes to do. So I have a couple slides here sort of showing the difference. May have to skip past that, but a flat install, or this is a setup tools style install where you have yoke and then the version and then .egg, and then that's either a zip file or a directory, and then you have to have this easyinstall.pth file to actually get that onto sys.path. That was supposed to support simultaneous versions of things side by side, but it turns out virtualenv does that better, or at least in a way that people understand more easily. So pip instead uses single version externally managed to install things like this, where the package itself goes right on sys.path, right in your site packages, and then the metadata goes next to it. And then the last part here is generating a record of all the files that were installed. I have no idea why it took until pip for a Python installer to do this by default. It seems obvious that if you're installing things, you'd want to know later what you installed, but I don't know. Fortunately, we now have a PEP that mandates that we're supposed to all do this, and distutils 2, the new hope for Python packaging, does do this. Okay, so the very last part of this talk is going to be one question that comes up occasionally is people want to use pip as an API. So I thought that might be a quick way to sort of see a little bit of pip's code structure in just a couple minutes, is to show you how you can use pip as an API from your own code if you want to install a package or uninstall or whatever. Pip isn't a great API, it wasn't really written for that, but it's not bad. It actually makes sense when you look at the code. There's some simple things we could do to make it a better API, like some sensible defaults for certain parameters and stuff, but okay, so we'll go with install here. Here's some of the code for install command, the basic structure of a command in pip. It has its name, its usage, sets up some options, the command line options in init, and then has a run method that actually does the work. Okay, so here's the code that you need to actually install a package using pip as an API. You need to set up a requirement set object. And this actually works. I tested this out. Works fine. Then you create an install requirement object. In this case, we're trying to install a yoke version 0.4.1. And so pip will parse that for you. Actually, Setup Tools does it again. And then you add your requirement to your requirement set. And you can add multiple requirements to your requirement set. And in addition to from line, you can also, there's a method to get it from a requirements file or various other things. And then you have to set up a finder, which is what actually goes out and does the terrible, terrible HTML link scraping that is the standard way of finding Python packages. And you give it there the URL to the package index, which can be any index you want. You can use your own index there. And then you call prepare files, you call install, and you call cleanup files. That's it. You've installed a package. So like I say, it's a few more lines of code than it may ideally be, but seeing all those lines of code lets you actually see what it's doing, and you can pretty much modify all the behavior you need to in there. There's a lot more to pip that we could look at, and we're not. Package finder. There's the whole version control backends thing. Requirements files, bundles, freeze, search, uninstall. Doing an uninstall programmatically looks pretty similar to the install, actually. Yeah, I don't know. So the future. So for virtualenv, one possible future is to get it integrated into Python itself. So you get Python and you immediately have a way to create virtual environments, since it seems to be popular. And it could also be a lot cleaner than it is if it was integrated into Python. As far as pip, probably the future for pip is to convert it to a wrapper around distutils 2, which will be going into the standard library and will be hopefully a much better solution for packaging than anything we have now. And so pip will just continue to provide some additional end-user conveniences that won't go into standard library, like things like requirements files and the VCS backends and other things like that. And then we can keep iterating on that, on those end-user facing features outside the standard library, and have the core packaging stuff in the standard library. At least that's my idea for the future. So I think that's the direction that we're headed. It'll take a while. We're going to need to be supporting Setup Tools packages for a long time to come, I think. So that's that.
We have about 5 minutes for questions. If anyone wants to, feel free to come up to the mic.
So obviously, as you said, pip is hopefully going to become a wraparound distutils 2, which is already coming, but the virtualenv solution to make things a little nicer is a little more ambiguous, at least according to the slide. So, I mean, what exactly would you want to see from Python itself in order to make at least, not necessarily getting virtualenv directly in the standard library, but at least make the life a lot easier so the crazy little hacks you just showed us and made us all cringe with can kind of at least start to go away to the point that what virtualenv does is a lot simpler and a lot less hacky.
I don't think it's actually that much change that's needed in Python. I mean, I think some pretty simple stuff in the site.py that is shipped with Python, some pretty simple support there would actually make it possible for virtualenv to be built in pretty easily. There's one, I think, I skipped past it pretty quickly in my slides, but Larry Hastings, I think,
Yeah, I'm Larry Hastings.
Hi, Larry Hastings.
Hi, we've never met.
I'd like to talk to you.
Yes, so Python B is exactly this idea. Merge, it's like virtualenv has to do an enormous amount of work because Python's an unwilling participant in this procedure. If you just make a few little tweaks to Python, I think it would make it very easy and a lot of work would go away. And so that's exactly what I want to do with Python B. I was talking to Ian about it last year. Nothing has happened for a year, but now is the time to talk to you.
I can interject.
Yeah.
Really quickly, there's going to be
Who are you?
I scheduled an open space at 11 a.m. tomorrow where we can talk about specifically virtualenv and Python core.
Thank you.
11 a.m. tomorrow.
Yeah, because speaking for the core devs, we're totally open to peps and patches to try and make this easier, because we realize, obviously, a lot of people use these tools, and we realize virtualenv is the bigger of the hacks between virtualenv and pip. So We're just looking for proposals, honestly, at this point. We're just waiting for someone to just do the legwork, but we'll most likely work with you to actually make it happen.
All right, cool. Will you come and represent Python Dev at the open space tomorrow?
Larry
Okay,
can, but
sweet, thank
I'll
you.
see if I can make it. But
Awesome.
there'll be also be some of us sprinting, so we can also just chat if you need to talk about anything.
Cool.
I'm wondering if you could talk for a moment about relocatable packages and how they work, or more specifically, why they so frequently don't work.
So the reason virtualenvs aren't relocatable is basically because when you install, a lot of things when you install them have scripts that come with them, and the way that those scripts get generated by setup tools, and thus also by pip, is they have well, actually, any script, even if it's a dist-util style script, will have a shebang line up top that directs to the interpreter that should be used to interpret the script, the Python interpreter. And so that's a full path pointing to the Python binary in your virtualenv. And I think sometimes maybe PTH files also have absolute paths in them. The point is, stuff gets installed with absolute paths. If you move the virtualenv, those absolute paths are wrong. That's why stuff breaks. So you can actually move a virtualenv if you go through and change all those absolute paths to relative ones or change them to the new location. That's just kind of a pain. Yeah, I have never used, yes. The question there was about a relocatable virtualenv. There actually is a -- relocatable option to virtualenv, and I don't use that because I don't trust it. I think what it does is it actually tries to go through your virtualenv and rewrite all those absolute paths, and that seems icky. I tend to treat virtualenvs as a deployment artifact. They're something, the information you need to create them is nothing more than a pip requirements file, so you just blow it away and recreate it whenever you need to. I don't see that much value to being able to ship them around, so I haven't worked on that.
Hey, thank you for the talk. I'm curious whether you try to look more into, as they are much more popular, the Jython, IronPython, PyPy, Python implementations. Have you looked at it a bit more, like how to use this stuff, like from virtualenv and more?
I'm not very familiar with Jython or IronPython. I've played with PyPy, and virtualenv does support PyPy right now, although it's been a little on and off. Basically, it mostly works because those other PyPy tries to copy things that CPython does, and sometimes it doesn't work, and then we have hacks in virtualenv where it says, if is PyPy, do this, and there's actually a fair number of those. So.
I would love to have pip fully supported in my company, but that's really not going to happen until pip does at least everything that easy install does, and pip doesn't do eggs. So in your exploration of Ian Bicking's brain, did you ever come across an understanding of why it doesn't support eggs?
Ian, are you still here? The question was, why doesn't pip support eggs? He was lazy and never got around to it.
All right.
Okay.
So virtualenv is quite usable, but I think virtualenv wrapper adds a lot of usability. I didn't hear him mention it at all in this talk, so if you could take 5 seconds.
Yeah, I guess the talk was inside pip and virtualenv, and that's outside virtualenv. But yeah, it is a really good tool, and I use it too. It's basically a bunch of shell scripts that establish some conventions where all your virtualenvs go in one place, and you have some nice shell functions to activate them and create them and deactivate them, and you can have hook scripts that run every time you activate or deactivate a virtualenv. So again, it's the whole activation thing, which, like I said earlier, it's very convenient. You should use it, but if you think that that's how virtualenv actually works, you're going to get confused. But yeah, very useful.